Hi, and welcome to Jerry's Engineering Corner. My name is Jerry D. Batista, and I am the Global VP of Porex's Virtek PTFE business group. Today we're going to talk a little bit about what happens when light energy strikes a surface. As you can see from the diagram to my side, when light hits a surface, it can either be reflected, either specular or diffuse, which means it goes in most different directions. It can be transmitted through the material, like a window glass. When light hits it, you actually can see the light go through. Or it can be absorbed. What happens when light is absorbed is that energy is usually transmitted into heat into the object itself. Energy absorption by surfaces is critical for us to see color. So the visible spectrum is made up of all colors of the rainbow. The color that we see when it's reflected off a surface is the color that is not absorbed by the material. So for example, when we see a green leaf, that green leaf is green because the leaf is absorbing all the other wavelengths of energy, but not the green color. So today's experiment, what we're going to do is we're going to show the absorption of different materials. Under UV light, materials behave quite differently. So something that actually may be very reflective in visible light can actually absorb in UV light. So the next step is we'll show you all the samples we have here that we're going to run in our little test case. So what we're going to compare today are some opaque materials. Opaque materials are materials where you get no transmission. It's all going to be either reflective or absorptive energy. So we have aluminum. I took plain aluminum and we've painted it several different colors to show the effect of different colors on the aluminum. And then we also have stainless steel. These materials tend to be more semi-transparent or reflective, but can be either transparent or translucent. Here we have ABS. White ABS is very commonly used for reflective media in the visible light, but you'll be surprised to see what happens under UV light. We have black ABS. We have high-density polyethylene, either natural, and then we have one that's painted to show the effect of something that's translucent versus painted. And then we have PTFE. We have a solid PTFE. Solid PTFE is again translucent. Some light will go through it, and some will be reflective. And then we have Virtek PTFE, which is 100% reflective PTFE. So first we're going to start with the opaque materials to show the effect of painting and how much absorption you're getting of these different materials. We'll start with the aluminum first. And as you can see, we're getting about 1,500 microwatts per square centimeter of energy in the box. And so we'll take this and we'll slide it all the way to the back. And you can see with aluminum, drops to about 1325. With gold, painted aluminum, $12.30. So you can see how the paint actually has a negative effect. So white, which you expect to be more reflective, is actually less reflective than the gold, $11.85. And then if you go to black, which you expect to be even worse, almost the same as white, $11.80. And then of course stainless steel, as most of you know, is not very reflective, and you can see $12.10. Next we're going to go to the plastic materials. First we're going to start with ABS. Again, ABS is very commonly used as a reflective media in visible light. Put the bright white ABS. Wow. $11.80. The same as the black painted aluminum. So here's black ABS, $11.35. So you can see it's a little bit worse. Now we're going to go to high density polyethylene. This will show what happens when you got something that actually transmits some light and reflects some. So you can see HDPE 1360. Not too bad. But if you take that same HDPE and you paint it white, you can see the negative effect that painting has. 1195. Then of course the Porex Virtek PTFE, which is 100% diffuse reflective. You can see 1480, basically no change. So almost nothing is being absorbed. And then you take the solid PTFE, which is translucent, which means some light's going through it. Again, almost no change. 1490, same. What that tells you is with the PTFE that very, very little energy is absorbed by PTFE, regardless of the form factor. So in a summary, as you can see, painting has a horrible effect on reflectivity. And this is because painting is usually use some kind of polymer to actually bind the paint to the surface. And polymers typically do not reflect light very well, especially in UV, where they actually absorb most of the UV energy. So as you can see the effect here, painting has a very negative effect on reflectivity, even making it worse than stainless steel, which is poor. The black versus white, not a big difference in the UV, whereas invisible it would be very, very big. Again, painting here for high density polyethylene, very negative. And of course, if you want the best performance, you have to go with Virtek PTFE, where you get the most reflectivity with very, very little energy absorption. Well, thank you for watching today. I hope you found that informative. If you want to see the rest of my video series, please go to porex.com/markets/reflective media. Well, that's it today for me, Jerry with a G.